Artemis moon samples, rewriting lunar history. When NASA's Artemis astronauts return to the moon, they won't just be planting flags and taking photos. They'll be collecting samples that could completely rewrite everything we thought we knew about lunar history. The last time humans brought moon rocks back to Earth was December 1972, during Apollo 17. That's over 50 years ago. Since then, our technology, our understanding of planetary science, and our questions about the moon have evolved dramatically. Artemis isn't going back to the same places Apollo went. Apollo missions landed near the moon's equator in relatively flat, safe areas. Artemis is targeting the lunar South Pole, a region that's never been explored by humans. Why the South Pole? Because it contains permanently shadowed craters that haven't seen sunlight in billions of years. These craters are cold traps, places so cold that water ice can survive indefinitely. And where there's water ice, there's history. Scientists believe these permanently shadowed regions contain ice deposits that are billions of years old, frozen records of the early solar system. Water molecules trapped in that ice could have come from comets, asteroids, or even the ancient Earth. By studying the chemical composition of lunar ice, we can learn where Earth's water came from, how the moon formed, and what the early solar system looked like. But water ice isn't the only treasure hiding at the South Pole. Artemis astronauts will also collect samples from the lunar Highlands, ancient, heavily cratered terrain that dates back over 4 billion years to a period called the Late Heavy Bombardment. During this time, the inner solar system was pummeled by asteroids and comets. The moon's surface is a time capsule. Unlike Earth, the moon has no atmosphere, no plate tectonics, and no erosion. Craters from 4 billion years ago are still there, unchanged. Rocks from the moon's formation are still sitting on the surface. When Artemis astronauts bring those rocks back, scientists will be able to date them with unprecedented precision using modern isotopic analysis techniques that didn't exist during Apollo. This could settle one of the biggest debates in planetary science: exactly when and how the moon formed. The leading theory is the giant impact hypothesis, the idea that a Mars-sized object called Theia collided with early Earth about 4.5 billion years ago. The debris from that collision coalesced to form the moon. But the details are fuzzy. How long did it take for the moon to form after the impact? Was the moon molten? How much of the moon came from Earth versus Theia? Artemis samples could answer these questions. NASA is also planning to send astronauts to collect samples from lunar swirls, mysterious bright streaks on the moon's surface that don't align with any geological features. Scientists think they're caused by ancient magnetic fields, but we don't fully understand them. If the moon once had a global magnetic field like Earth's, that changes everything we know about its interior structure and thermal history. Artemis will also bring back samples from volcanic plains and lava tubes. The moon was volcanically active billions of years ago, and understanding that volcanism helps us understand the moon's internal evolution. Some scientists believe lava tubes could be used as natural shelters for future lunar bases, protected from radiation, micrometeorites, and temperature extremes. But here's the most exciting possibility. Artemis samples could reveal evidence of ancient life, or at least the building blocks of life. If water-rich comets and asteroids bombarded the early moon the same way they bombarded Earth, they could have delivered organic molecules, amino acids, sugars, nucleotides, to the lunar surface. On Earth, those molecules led to life. On the moon, they were frozen in place, preserved in ice for billions of years. Finding organic molecules in lunar ice wouldn't prove life existed on the moon, but it would prove that the ingredients for life were widespread in the early solar system, and that increases the odds that life exists elsewhere. Artemis astronauts will use advanced tools that Apollo astronauts didn't have: portable mass spectrometers, ground-penetrating radar, robotic drills, and real-time chemical analysis. They'll be able to identify the most scientifically valuable samples on site and bring back exactly what scientists need. NASA is planning to collect hundreds of kilograms of samples during Artemis missions, far more than Apollo brought back. Those samples will be stored in state-of-the-art facilities and studied for decades. Some samples will be sealed and stored unopened, reserved for future generations with even better technology. Artemis isn't just about going back to the moon. It's about unlocking the moon's secrets. Secrets that could rewrite the history of the solar system and reveal the origins of water, life, and Earth itself. Like, share, and subscribe for more on humanity's return to the moon. And as always, keep looking up.